All right, I'm going to restart because I got confused too while I was doing it.
All
All right.
I'll get out of here.
So say this is your nav, your start nav, your start point, and then you have your first point, your second point, and your final point, which is your third point, right? And so you're going to go, this is one leg, another leg, your final leg. You have total time, or I'll say leg time first, and total time. And that's where the confusion comes in. So let's say, just for analysis purposes, that each leg is 60 seconds. So you start here at 0 seconds. Then you would start here at your first point. If you're perfect, you get there at 60 seconds. Your second point, you get there at 120 seconds. And finally, at your third and final point, you get there at 180 seconds. That is your total leg time. Oops, didn't want to do that. That is your total leg time right here. Now, let's look at this from the perspective of a clock. Let's say you start at midnight. It'd be nice to do a night nav. And then after 60 seconds, if you're perfect, you're going to be here at 0001. You're going to be here at 0002 at your second point, and your final point should be at 0003, right? So that's another way to see that your total leg time is 3 minutes or 180 seconds, right? So let's say, though, that you make some mistakes and you're 30 seconds early here. Now, you still start at midnight, but now you get here, well, now I need more zeros. You get here at midnight and 30 seconds past midnight instead of a minute past midnight. But then say that you decide to always stay 30 seconds early till the very end. Then what happens? Then you're going to get here at 1:30, and you're going to get here at 2:30. So you wanted to get there at 3 seconds past midnight, but you got there 30 seconds earlier than that. So your total leg time with penalties is plus 30, right? You're getting 30 off of what you planned. And you also had that 30 off of this initial leg time, because my leg time here was 30 seconds. My leg time here was still 60 seconds. And my leg time here was still 60 seconds. So you get a leg time of 30 with penalties. That would be in blue, 30 seconds. And then you get another total time penalty of 30 seconds here because you're missing 30 seconds. That's the discrepancy. So overall, your absolute penalties are 60. Now, say we have a similar scenario, so I'm just going to copy this. Copy, paste. And let's build another scenario. So we still have the same nav, but now let's say we make other decisions. So we're still 30 seconds early on the first one, but then we decide, hey, let's slow down a little bit. So we're going to be only 15 seconds early on the second one. And then let's say that at the last one, we just stay 15 seconds early. Now what's going to happen? Well, you're still going to start at 000000. Then you're going to get to 000130 because you wanted your first leg, sorry, it should just be 30 seconds. You wanted your first leg to be 60 seconds, but then you were 30 seconds early, so your first leg is actually 30 seconds, right? Your first leg is now 30 seconds. Now, how much is your second leg? Well, if you're 15 seconds early, that means that your leg lasted 15 seconds more than it should have, right? Because if you were still 30 seconds early, then you would have gotten there at 1:30. So you would have gotten there at 1:30, but now you're getting there at 1:45. And you wanted to get there at 02. So essentially, that's what it means to be 15 seconds early. How much did your total leg last? Well, you went from 30 seconds to 1 minute and 45 seconds. So overall, it's 2 minutes and 15 seconds. So you're getting 75-second leg here, right? And then finally, here, you're still 15 seconds early. So you wanted to get there at 03, but now it's going to be 02 and 45 because you're 15 seconds early. So how much time elapsed there? Exactly 60 seconds. So you're getting what? 30 penalty here, a 15 penalty here, a 0 penalty here. That is for your leg time. So you would get 30 plus 15 plus 0, 45. For your total time right here, you get another 15, right? Because you got at the end at 2:45 instead of 3. So overall, what are you getting? 45 plus 15. So your total penalties, absolute penalties, are still 60, right? Well, let's look at another scenario. And what you're going to find out, this could be actually a mathematical proof. What you're going to find out is that as long as you always keep some lead, the total amount, the absolute penalty breakdown will still be the same regardless. So let's do one last scenario. I'm just going to copy this. And then I'll show you what Riley came up with, which is a super cool graph. That's the proof that he's a genius. And I'll show you how to do it, how to make it more visual. Okay, so say you decide you're 30 seconds early again, and then you decide to be on time here, so 0, and be on time here. Now what does that mean? Let's do the calculation just one more time. Well, if you're 30 seconds early, you start at 0, 0, 0, 0, and then here you get there at 30 seconds instead of a minute, because your leg should have lasted a minute. So what's your total leg time? It's 30 seconds. Okay, now you're 0 here. So what does that mean? That you got there at 2 minutes. So you got here exactly at 2, the minutes are right here, 2 minutes. So how much is that if you look at the clock? Well, that is, we need 30 seconds to get to 1 minute and another 1 minute. So that is a total of 90 seconds here. And then finally, you got on time on your last leg too. So you got 0, 3, 0, 0. So from 2 to 3 minutes, that is another 60 seconds, right? So now what's happening? Let me see. Now let's look at the penalties. Well, here you get 30 seconds off, so plus 30 points. Here you're 30 seconds off, so plus 30 points. Here you're 0 seconds off, so plus 0 points, right? So your leg time penalties are 30 plus 30 plus 0, which is 60. Now you look at your total time. What is the discrepancy between what you planned and what you actually did? 0. So your absolute penalties are still 60, all right? So here's the bonus. The bonus is if you have a graph where this is the time axis, and this is in seconds, and actually, before I do the bonus, now let's say that you have one more scenario which is where you ping pong, essentially. If you ping pong, that's going to get you the most amount of penalties, and I'll show you why. Say you're 30 seconds early. So you're 30 seconds early. Then you're like, oh no, we need to slow down. So you end up being 15 seconds late. And then, oh my gosh, we're late. We need to speed up. So you get to 0. So here you don't have any overtime. Right, so let's do the clock real quick. So we start at 0, 0, 0, 0, 0, 0. And then we get here 0, 0, 0, 0, 30, because we're 30 seconds early on a 60-second leg. Then we're 15 seconds early. So that means we get here at 0, 0, 0, 0, or 0, 0, 0, 1, 45 seconds, right? So we're 15 seconds early. So to go from 30 seconds past midnight to 1 minute 45 seconds past midnight, how much is it? It's 30 plus another 45. So that's 1 minute and 15 seconds. So our leg here lasted 75 seconds, while this leg lasted 30 seconds. And then finally, here we're on time, so we're going to get there at 0, 0, 0, 0, 3. Or the 3 goes, oops, 3 goes here. So now, this leg also lasted 75 seconds, right? Because to get to 2, you need 15 seconds and then another minute. All right, so now, your total time is 0. So you get 0 penalties for total time. But now you're 30 seconds off here, so you get penalty here, plus 15, plus 15. So you get a total penalty of, hold on, I think I did this wrong. Made a little bit of a mistake here. This would be 2 minutes and 15 seconds, right? Because I said 15 seconds late. So this would be more. This would be 30 seconds there, and then you have 30 seconds to get to a minute, and then another 15 over, so that is 45 seconds on top of the 60 seconds. That's 105 seconds with a penalty of 45 seconds. And then from 2:15 to 3, that is a leg that's actually 45 seconds long, so you're 15 seconds penalty here. So you get 30 plus 45 plus 15, which is a total of 60 plus another 30. So the absolute penalties will be 90 seconds. And that's because you ping pong. That is, you were first early, then you were late, and then you were on time. So the bonus is, say you have this graph, and say this is the time axis in seconds. And this is no time deviation from the point. That's what this 0 represents right here. So say you are, let's say the first scenario, we'll do it in this color. Say you're at 0. This is your start. Then you go to your first point, and you were 30 seconds early. Or I guess I should do it. I said 30 seconds early was a minus, so we'll go down. 30 seconds early. So say after your first point, you're right here, and this is 30 seconds. Right? Then, what was the first scenario? 30 seconds, 30 seconds, 30 seconds. Your second point, you're still at 30 seconds. Your third point, you're still at 30 seconds. If you look at this distance right here, it's 30 seconds. Double that, and that's your total penalty. 2 times 30 seconds, 60. The second scenario was right here. You got 30, 15, and 0. So you start from here again, but then you're 30, so this is also your second scenario, but then you get to 15, and then you get to 0 here at your third point. So this is what it looks like. Well, what is your total largest distance from the 0 axis? It's still 30. So your total penalty is still 30, right? Because you look at the largest regression, which is this, in both cases, and you multiply by 2. Let's look at the third scenario. So third scenario would be 1, 2, 3. So 30 seconds early, then 0, 0. So your third scenario, you start from here, then you're at 0 at your second point, and you're at 0 at your third point. But your largest deviation is 30. You multiply by 2, the total penalty is 60. Now we look at the last scenario. That would be, we'll do it in red. That's the one that you don't want to do. And that would be right here. Now what we're going to do is we're 30 seconds early. 30 seconds early. Then we're 15 seconds late. So now we're here. And then we are 0 seconds on our third point. So we go like this and like this. So now we have, if we look at the total deviation or the total regression, it would be, oops, didn't want to do that. It would be 30 and 15. So total penalty would be 2 times 30 plus 15, which is 90 seconds. So the bottom line is, if you start early and early, if you start early and early, it doesn't matter how you distribute the earliness of each point, as you see here. And if you start late and late, because it doesn't matter how you distribute your lateness, as long as you stay here, you're going to get that same deviation from 0. It could be that scenario, or it could be this. Nope, don't become more late. It'll still yield the same result. Well, I hope this was useful. It took me a while to figure it out, but I got there. All right, and good luck on your navs.